एसएसबी भरना है तो कितना कॉस्ट जाएगा?
सर बहुत ज़्यादा कवर हो जाएगा।
नहीं, practically if you are saying for long transmission lines, say is okay for your switchyard, substation, receiving station because of your limited area, but how you can make it economical for your long transmission lines?
मेरे एक सर्किट ब्रेकर में 30 kg ड्रेस लगता है, एक सर्किट ब्रेकर। अगर मैं लॉन्ग ट्रांसमिशन लाइन में यूज करूँगा तो कितना kg सर्किट लगेगा?
सर उसमें नाइट्रोजन भी मिक्स कर सकते हैं, इसमें नाइट्रोजन 1/4 भी मिक्स कर सकते हैं।
हाँ तभी भी कितना पड़ेगा? और कॉस्ट इफेक्टिव तो जस्टिफाई नहीं होगा। और दूसरा उसका अगर लेसेस लीकेज हुआ तो
सर इंग्लिश ये डिफाइन करना पड़ेगा उससे।
उसको प्रोटेक्शन क्या है?
प्रोटेक्शन से बैटरी टैंक में जो घर से सब प्रोटेक्शन पूरा वेल्डेड रहता है वो।
कहाँ पे यूटिलाइज हुआ है?
इंडिया में नॉर्थ चेन्नई साइड में यूटिलाइज हुआ है और आउटर कंट्रीज में
कहाँ जो वहाँ पे लिखा हुआ ना स्लाइड में? हाँ इंडिया में कहाँ पे?
इंडिया में नॉर्थ चेन्नई में यूटिलाइज हुआ है।
नॉर्थ
चेन्नई में
रेफरेंस आपने देखा है, चेक किया?
Yes, sir.
कौन से लाइन पे वो नहीं? नॉर्थ चेन्नई पे ऑन विच फीडर इट इज यूटिलाइज्ड? ठीक है, ठीक है।
Next participant Manoj Rajbar and Rehan Shah.
हेलो
Good afternoon, everyone. Respected judges, teachers, or all friends. Myself, Manoj Rajbar. My group member is Riyan Shah. My topic name is EVBMS with charge monitoring, fire protection. A battery management system is used in electric vehicle to keep the battery safe and working properly. It checks battery voltage, current and temperature during charging and use this project includes charge monitoring and fire protection. It is if the battery become too hot or unsafe, the system cut the power and give a alarm. This help to prevent damage and improve safety.
Good afternoon, everyone. My name is Rehan Shah. This slide shows the problem statement of our project. Electric vehicle batteries can become unsafe due to overcharging, high temperature, or short circuit condition. When these problems occur, the battery may get damaged, and in serious case, it can even cause fire hazard. Because EV batteries stores continuous monitoring during charging is very important. आर्किटेक्चर ये माइक्रो कंट्रोलर है और ये सेंसर है सब। तो ये सेंसर सब बैटरी पैक से कनेक्ट रहते हैं। ये हमारा कंटिन्यू चार्जिंग के टाइम डिस्चार्जिंग के टाइम अपना टेम्परेचर वोल्टेज और करंट सेंस करता है और सेंस करके अपना कंट्रोलर को देता है। तो कंट्रोलर प्रीसेट वैल्यू के साथ कंपेयर करके अपना इसको प्रीसेट वैल्यू के साथ कंपेयर करके अपना चार्जिंग डिस्चार्जिंग करता है इसका और इस पे एलसीडी पे अपना शो करता है वोल्टेज टेम्परेचर सब। हार्डवेयर माइक्रो कंट्रोलर या आर्डिनो यूनो यूज किया है। ये अपना कंट्रोलर प्रोसेस सिस्टम है और अपना वोल्टेज सेंसर वोल्टेज मेजर करता है, करंट सेंसर करंट मेजर करता है, टेम्परेचर सेंसर टेम्परेचर मैनेज करता है और रिले मॉड्यूल अगर ज्यादा वोल्टेज चले गया तो अपना पावर कट ऑफ करता है और डिस्प्ले जो अपना टेम्परेचर करंट वोल्टेज में डिस्प्ले पे शो करता है माइक्रो कंट्रोलर के थ्रू। और बजर ज्यादा ओवर टेम्परेचर होने पे बजर बजता है, टेम्परेचर ज्यादा गया तो बजर बजता है। और बैटरी पैक यहाँ लिथियम आयन यूज किया है और पावर सप्लाई 5 वोल्ट डीसी अपना माइक्रो कंट्रोलर को सप्लाई करने के लिए और कूलिंग फैन दिया है कि अगर टेम्परेचर ज्यादा गया तो अपना कूल करने के लिए। वर्किंग प्रिंसिपल Working principle. This slides explain the working principle of our project. The battery management system continues monitoring battery voltage, current, and temperature using sensor. All the sensor data is sent to the Arduino Uno microcontroller, where it is processed. The controller compares the measure value with preset set limit. During charging, the system checks for overcharging, overheating, or abnormal current condition. If any abnormal condition is detected, the relay automatically disconnects the power supply. Same time, buzzer alarm is activated to give warning. If the battery condition is charging normally, the operation is continue normal. This working principle protect the battery from damage, reduce risk, improve battery life, and increase overall EV safety. Feature. This slide shows the features of our project. Real-time battery monitoring. एलसीडी डिस्प्ले से हम लोग मॉनिटर करते हैं रियल टाइम में और चार्ज लेवल इंडिकेट होता है डिस्प्ले पे ही और ओवरऑल प्रोटेक्शन ये जो प्रोटेक्ट ओवरऑल करता है पूरे बैटरी को और ओवर टेम्परेचर प्रोटेक्शन फैन से प्रोटेक्ट होता है टेम्परेचर सेंसर से और ऑटोमेटिक बैटरी रिले से कट ऑफ होता है डिस्कनेक्ट होता है बैटरी पैक से पावर फायर स्मोक डिटेक्शन फायर स्मोक करता है अलार्म बजर से अपना अलार्म बजता है और इम्प्रूव ये पूरा सिस्टम बैटरी की लाइफ को इनहैंस करता है। Conclusion. This system keeps the battery safe by monitoring charging and temperature. It stops the battery if any unsafe condition happen and gives an alarm. Improves safety, prevent damage and increase battery life. Thank you.
Please completed this project. BMS. So, what are the things that you have managed in your project?
Temperature, current, voltage, ये manage करता है इसके डिस्प्ले शो भी करता है।
3 parameters.
Yes.
Voltage, current, and temperature.
Yes.
So, how long the temperature it is showing on your?
35 टेम्परेचर का सेट है प्रीसेट वैल्यू कंट्रोलर पे। अगर 35 के ऊपर गया तो अलार्म बजता है और वो फैन लगाएगा डीसी, वो डीसी फैन चालू होता है कूलिंग के लिए और 35 के नीचे गया तो ऑटोमेटिक बंद होता है सब।
Means considering certain data, then you have managed your project.
Yes.
Then current range.
Current range.
Yeah, current is only showing on your display.
Yes. Yes, current is only flowing और रिले पे भी वो सेट रहता है।
फैन जो है वो बस टेम्परेचर
के लिए हाँ।
क्या ये किया था
आर्किटेक्चर
ये माइक्रो कंट्रोलर जो था हाँ ये इसको ये कैसे किया
C++ इसको
किसने बॉन्ड किया प्रोग्राम? Who has bound the program? Who has written algorithm?
वो लिखवाया बात कोडिंग का बाकी सब कनेक्शन हम लोग
वो बाहर से
वो बाहर से
कंट्रोल करना है ना, तो माइक्रो कंट्रोलर।
यस, रेडी पे प्रोजेक्ट है।
करंट सेंसर और ये सब सेंसर तो ये कहाँ से
सेंसर
परचेज कर
परचेज इज रेंट रोड। यस,
इसमें डाटा स्टोर भी करते हैं कुछ आगे का प्रोसीजर क्या है, यानी इसको आपको बढ़ाना है प्रोसेस, आपने ये प्रोडक्ट बनाया इसका फ्यूचर स्कोप क्या है, कैसे बढ़ाएंगे?
फ्यूचर स्कोप जैसे अपना मोबाइल इंटीग्रेशन, नोटिफिकेशन, टेम्परेचर आता है, लेकिन हमने खाली प्रोटोटाइप बनाया है छोटा अभी, ज़्यादा फ्यूचर इंटीग्रेशन नहीं है।
Means if you are driving your vehicle and if anything happen with the battery, so that message will go on the mobile.
यस, मोबाइल इंडिकेट करेगा, मोबाइल को नोटिफिकेशन आएगा बैटरी पे ऐसा हो रहा है तो रोक सकते हैं गाड़ी ऐसा।
ये रोक सकता है, लेकिन आपको बस यहाँ तक रोक ही सकता है, एक्चुअली वो करंट क्यों बढ़ा है ये आपको सर्च करना है नेटवर्क, ऐसा ना?
Increase in current may be because of many reasons.
यस,
And just driving the any vehicle, you know that इसका पूरा dynamic operation है. Mechanical aspects and electrical aspects with this thyristor family, everything will come there. And you already know, already in the program. अभी कितना वोल्ट पे चार्ज कर रहे हैं बैटरी को?
बैटरी हम 12 वोल्ट।
ठीक है,
थैंक यू।
Next participant, Vedika Praveen Lingayat and Shravani Sandeep Shigawan.
Good afternoon, respected judges and everyone who are present here. I am Vidyapeeth Navi Mumbai, along with my teammate Shravani Shigwan. We are going to do a presentation on a topic prediction of lightning strike by using artificial intelligence technique for transmission line fault detection. The contents in our presentation are introduction, conventional methods of protection.
Start. Because time you have to manage. That is why.
Okay.
See that your slides. You have to manage this.
India's transmission line is vast for about 292,000 circuit kilometer. It is such a vast system which is vulnerable to the power outages. Lightning strikes are one of the main reasons for causing transmission line faults. Therefore, by using AI-based techniques like PCA and SVM along with efficient powerful relay, we can identify the lightning stroke fault very easily. Next slide. Now, here in this slide, there are conventional methods. Basically, there are two conventional methods. The first method is impedance-based method, impedance-based protection method. Here in this method, there is mainly use of Fourier principle. In this method, the operating time gets increases and inversely it slows down the process of fault identification. The next method is transient-based protection method. Here in this method, although the transient carries information fastly, but it also suffers from reliability issue. It cannot discriminate the fault clearly. Therefore, these both methods are not suitable for light fault identification as they are not fast and accurate as well.
Now coming to the objective to an implementation of protection methodology by using artificial intelligence technique for lightning stroke that produce fault is over in transmission line. Second objective to be capable of extracting pattern from lightning stroke. The third objective is identifying whether lightning stroke produce fault or not, reducing the operation time and improving the traditional protection performance.
Here in this slide, there is lightning phenomenon. Basically, during thundercloud, when two charges get separated, the voltage gets increases among those two charges. The upper part of cloud becomes positive and lower part of cloud becomes negative. During this process, when air cannot able to hold that pressure, the dielectric strength of air gets break down and an enormous energy gets releases within a high temperature about 1500 degrees Celsius.
This slide is lightning problem in power system. The first discharge path is between leader core of lightning stroke on the earth. The second is called as the effects on earth. The second discharge path is between lightning head and earth conductor. It's called a black flash over. The third discharge path between leader head and face conductor is called as shedding failure. What is meant by principal components of analysis? Where extracting the relevant information from data sets and all analyzed signal are computed in new orthogonal variables is called principal components. There are 19 data sets. Consider the parameters of flash peak, current, amplitude, polarity, tower footing, resistance, impact, and distance.
This is a normal table before normalization process. There are total 20 testing signals along with the mentioned parameters: lightning current amplitude, distance from relay point, tau footing resistance, polarity of lightning stroke, impact point, lightning flash on. Here, there is positive and negative polarity. For one, we have denoted the negative polarity, and for two, we have denoted the positive polarity. Here, there are three phases: R phase, Y phase, and B phase. For step 1, so now for step 1, by getting some data in this presentation, we have considered lightning data, and it is normalized by lightning stroke matrix. This is our normalization data set. As I said before that we have denoted one for negative polarity and two for positive polarity. There are same 20 testing signals present here along with the mentioned parameter. This data set is mainly used and tested for our PCA based model for light stroke identification. Here for step 2 we are going to subtract the mean. To find out the mean vector, we are going to subtract the mean from each data dimension. The mean will be 0. This is the extracted data from all data set. Lightning current amplitude data will be 0.36325. Distance from relay point will be 0.32899. Tau footing resistance, polarity of lightning stroke, impact point phase ground, lightning flash on. This is our new data set after subtracting the mean values. Here we can see all the columns are filled with starting with 0. That means previously we have calculated the mean. In that slide I have already told that the mean will be 0. So you can see here in this column.
Step 1, Step 3 and Step 4. Calculate the eigenvalues and eigenvectors of covariance matrix. This is the covariance matrix. By using covariance matrix, we calculate the covariance factors. Vectors. Here the data compression and reduce the dimensional coming into it. Hence, by using principal components analysis, it is possible and extract the new variables corresponding to principal components.
So this machine is a support vector machine. Here in this machine there is separation of two groups. By using a line called hyperplane, the closest points are called as support vectors. Here it is margin. This machine is used for basically classification. This is flow chart. Basically, this is identification of lightning stroke flow chart. Here, firstly, we can obtain lightning stroke current IP. Then we will pre-process lightning peak current and with specific polarity with impact point. Next, we will apply PCA to given data set. Then we will test it is against the train SVM fault classification network. If the system is having fault, the output will be 1. If the system is running normally, the output will be 0. Now coming towards the result, we have total tested 20 test signals. Here we have mentioned few in our presentation. Test signal number 1, lightning current amplitude, it is 150. Current distance from relay point, it is 20. Tau footing resistance is 20. Polarity of lightning stroke is 1, impact point phase ground is 2, lightning flash on is for live wire is 1, middle span it is 3, for tower it is 2. That means our system has occurred fault, it has detected fault. Now for testing 2, lightning current amplitude is 120, distance from relay point is 20, tower footing resistance is 10, and all the values which are mentioned here. Here the system is running smoothly. It is running normally. It has not detected the fault.
All these are your conditions. Now go for this conclusion. Otherwise, time is running. Show the conclusion.
Okay, basically coming towards the conclusion, we have used AI-based techniques. In that AI-based techniques, the examples are PCA and SVM. Through that, we can identify the light stroke detection fastly and accurately. Thank you.
Now this test data and for these various test signals, you have done that statistics all data or
Yeah, we have done statistics.
and all that tables and all the data.
Yeah, we have done that.
So means both of you are aware about the normalization also.
Yeah, absolutely. We are aware about the normalization.
On your own you have prepared all this or somebody has guided you?
Yeah, our HOD has guided us. It is also a third year project. Yeah.
So direct stroke or indirect stroke like
Direct stroke or indirect stroke also.
it's for any.
Yeah.
But you have done this statistical analysis for what kind of lightning stroke?
Basically, we have given or fitted some specific type of information to the relay. We have done some connections there. Then relay will give the signal to the transmission line and it will protect our transmission line. By using the techniques as I said before, PCA and SVM, support vector machine, principal component analysis. Yeah.
So vector machine you are aware.
Yeah.
And your title AI.
Yeah.
So where it comes?
Yeah, principal component analysis and support vector machines. These two are our AI tools.
Okay.
By using those two AI tools, we have done our presentation. These two AI tools, we have given that information to the relay, and with that we can control light striking, or we can protect our power system through it.
Your first word is what? Your title.
Which
Your first word of your this topic. Very first word.
lightning stroke prediction,
No, no.
identification of lightning stroke prediction. Okay, lightning problems in power system.
Your topic name is what?
Identification of lightning stroke by using AI tools like PCA and SVM. Basically, it is somewhere like this.
Prediction of.
Yeah, prediction of lightning strike by using artificial intelligence technique for transmission
That
network.
prediction you have used that two tools, no?
Yeah, for prediction we have used those two tools.
Because lightning is a natural phenomenon. We are never going to clear it like other forms.
Yeah.
But the severity of that is we are going to reduce them. And that is why I'm asking, that is the prediction. Prediction of your lightning strike.
Yeah, that is prediction.
Okay.
Thank you.
Where are you collecting that data?
Relay. We are connecting the data to the relay, and relay is connected to the transmission line.
Show me the chart.
Chart.
तो
Okay.
डाटा कुठून आला?
हा डाटा आम्ही बेसिकली MIDC किंवा स्पेसिफिक रिसर्च पेपर्स मधून तो कलेक्ट केलाय.
आता रिसर्च पेपर म्हटलं तर एखादा आठवतोय का तुला नाव? कुठल्या पेपर ऑथर वगैरे काही रेफरन्सेस दिलेले आहेत का?
हा रेफरन्सेस आहेत.
प्रेझेंटेशन मध्ये
प्रेझेंटेशन मध्ये आहेत रेफरन्सेस.
दुसरीकडे कुठे आम्हाला शो मी द रेफरन्सेस. अदरवाइज हार्ड कॉपी. आय थिंक दॅट इज देयर. या.
Yeah, those are the references.
पुढे दाखवा अजून काय. अजून पुढे. हो.
आणि ते दोन्ही AI टूल्स आहेत तो कुठे आहे तुमच्या PC मध्ये?
हा PC मध्ये.
आणि MATLAB जे दाखवलेलं आहे ते तुम्ही MATLAB मध्ये प्रोग्राम लिहिला?
हा MATLAB हा नाही, पण त्याचं आमच्यावर अजून काम चालू आहे.
नाही आता तो जे तुम्ही काही इथे आम्हाला रिझल्ट दाखवले ना,
हा.
टेस्ट 1 टेस्ट
ते सर वी हॅव ऑलरेडी 300 टेस्टिंग सिग्नल्स रिझल्ट प्रेझेंट इन अवर PC लाईक वी ऑल्सो हॅव राईट नाव विथ अवर सर्व्हर लाईक दे हॅव दॅट.
MATLAB तो प्रोग्राम लिहिलेला नाहीये.
नाही, त्याच्यावरती आमचं काम चालू आहे.
नाही मग काम चालू आहे तर रिझल्ट कसे आहे?
नाही
टेस्ट
रिझल्ट
सिग्नल कसे आले? टेस्ट सिग्नल
मला सर क्वेश्चन रिपीट करा.
हे बघा, तुम्ही टेस्ट सिग्नल्स आम्हाला दाखवले प्रेझेंटेशन मध्ये.
हा.
सर हा फॉल्टी आहे, हा नॉर्मल आहे,
हा.
हा प्रेडिक्ट केला आहे, मीन्स
हा.
गोइंग टू बी अ फॉल्ट. म्हणजे यू हॅव ऑब्झर्व देयर आय थिंक 5 टेस्ट रिझल्ट्स आर देयर.
Yeah.
तर हे टेस्ट रिझल्ट बेटा केव्हा येतात? जेव्हा आपण काही प्रोग्राम केल्यानंतरच येतात ना.
हो.
मग तेच सर विचारतात. आणि मग तुम्ही
ते सर ऑलरेडी डिटेक्ट केलेले आहेत, आणि ते म्हणजे आम्ही त्याच्यातले टोटल 20 मी जसं मेन्शन केलं ना प्रोजेक्ट मध्ये.
आम्हाला हे पाहिजे की यू हॅव वर्क ऑन दिस.
या वी हॅव वर्क ऑन दिस.
हाऊ कॅन यू आर सेइंग दॅट सर आमचं काम
सर बेसिकली आम्ही जे स्टार्टिंग पासून प्रेझेंटेशनचं मेथोडॉलॉजी वगैरे सगळं म्हणजे सांगितलं होतं ना, त्याच्यात ते सगळं होतं की आम्ही मॅट्रिक्स असा काढला, लाइटनिंग डाटा घेतला, मग तो नॉर्मलाइज केला, त्याच्यानंतर मग आम्ही मीन काढलं, मग ते
तो MATLAB तो प्रोग्राम हा ते हे स्क्रीनशॉट कुठून घेतलं?
सर हे काढलेलं आहे जसं की आम्ही डाटा आधी नॉर्मल
प्रोग्राम मधून तुम्ही काढलेलं आहे.
हा.
म्हणजे यू हॅव वर्क ऑन दॅट.
या वी हॅव ऑलरेडी वर्क ऑन दॅट.
हे कुठून कॉपी करून नाही टाकलेलं आहे.
वी हॅव ऑलरेडी वर्क ऑन दॅट.
हां.
ओके, थँक्यू.
Next participant, Vaibhavi Khanthale and Shalaka Maskar.
Good afternoon, everyone. Good afternoon, respected judges and all dear friends. We are going to present gas insulated transmission line. Gas insulated transmission line. So what is basically question is the what is gas insulated transmission line? The abbreviation is GIL. As we have know the in crowded areas how the transmission line is insulated or how the transmission line can be installed. As we don't see from our eyes that is underground or in a insulating or enclosure type. So the GIL is installed in a metallic shield. Installed in a metallic shield and it is insulated with the SF6 or SF6N2 gas. First GIL is installed in 1975. In India, it is also practicing, but not in a majorly. GIL is installed in the combination of gas insulated switch gas. The switchgear is also installed in that metallic shield, and that we can't see from our eyes. That is inbuilt in that metallic structure. The need of GIL, as we know, day by day, the urbanization and the power demand is increasing. Power demand is increasing. That's why we don't provide a high power extra high voltage or UHV ultra high voltage transmission line. Then GIL is very helpful or useful for that. GIL we can install in underground tunnels and crowded areas, and it is very efficient for economical and eco-friendly also. GIL maintenance is low. If we install it once, then its service is for 40 or 50 years longer. Design of GIL. GIL is installed in a metallic shield, and in that shield a conductor is placed. The conductor is of aluminium and the outer insulation is given by gas. That gas is SF6 or N2 gas mixture. That gas mixture has a high dielectric strength because as we use many material for a dielectric strength such as air or oil, but that is not for long lasting, or it gives sometimes after the dielectric strength with poor or make maintenance to do. But SF6 has longer life and gives longer service as compared to other material. This is how the GIL enclosure looks. This is aluminium conductor, and this blue lighting is known as the insulating gas. This enclosure is insulated with outer coating. This is of metal and gives safety to the outer part, and this is post insulator. This is the block diagram of how the GI terminal, how the line comes and goes to the load. As we get power source from the generation, it goes to GI terminal with the metallic enclosed SF6 gas enclosure, and comes to the conducting part or through conductor and gives insulating gas to it. Then after that enclosure gives us grounding. We give ground to that enclosure and load receives to the end. Application of GIL in modern power system. Underground transmission in dense urban areas, limited space. Where the space is limited, we can install there GIL. As the GIL takes less space compared to overhead transmission line. Gases or the other materials such as which gives dielectric strength, that is renewable sources, and we can use it for renewably, and it is also one's application. Transmission through environmentally sensitive regions. The regions where environment is highly sensitive, or we can't install their overhead line or underground line, then GIL is very useful for that. Such as the railway station, metros or tunnel areas, GIL can be helpful. Role of GIL in modern power technology. GIL is enclosed with SF6 insulating gas, which supports extra high voltage and ultra high voltage levels. GIL provides high voltage capacity, so we can install it for nuclear power transfer or power system for high voltage. High current density and thermal stability used by GIL. GIL has low dielectric strength and less transmission losses. It provides safety and operational reliability. As we once install, then maintenance will be less for GIL. As I said before, GIL is eco-friendly insulating gas mixture. The gas is installed in an enclosure, that's why that is not harmful for environment. Costly efficient. The cost of the GIL transmission line in India, according to per kilometer, the cost is 15 to 30 crore in India, and the gas cost is SFC gas cost is 8,000 to 15,000 per kg.
Now we see the GIL suitable. GIL is suitable for high reliability for power plants, nuclear facility, data centers, underground substation as compared to overhead transmission line. Role in future, smart and digital grid compatible with real-time monitoring system and condition based on maintenance, digital substation it digitally operate or automatically operate, and smart grid technologies like IoT sensors. Conclusion. For future power system, GIL is not just for a transmission line but also a smart and sustainable pathway, or it is more efficient.
This is how the GIL system looks. Its separate enclosure is for a single phase, in which suppose this enclosure means for one phase R, Y, B. Separately, one phase is installed in each enclosure. This is a single phase install. This part looks here the circuit breaker or other equipment isolators such as we can't see, but there is installed in it. This is a gas insulator switchgear that is installed between them. This is how they look. And this is the structure of conductor. This is insulating conductor. This is inner aluminum conductor, and the gas is surrounded by it. And this is metallic enclosure that we see before diagram. And insulating coating, that's on the metallic part.
How this is the cost efficient design?
It is cost efficient if we install once, then for many years it gives service.
How long it will give the service?
More than 40 to 50 years.
And,
How it is eco-friendly?
It is eco-friendly as compared to overhead lines. Animals or birds or any environmental obstacles or conditions occur that will not affect GIL.
You are using SF6, which is hazardous to environment. Then how it is eco-friendly?
That is enclosed, so that is not harmful for environment.
Enclosed, but there may be leakages. There will be leakages in 40 years.
But the timeline is more, so that
But it is it mainly affect the ozone layer. Therefore, it is nowadays we are considering to eliminate SF6 from our power.
as we install in underground, then it is not harmful for ozone layer.
again, the limitation comes there. At all the places because of rain and all other conditions, the underground system is again expensive.
Yes, it is expensive, but increasing urbanization is also.
You can use underground cables, no? Why we have to go for GIS?
Underground cable service or lifeline is less than GIL.
What is the difference? केबल का भी लाइफ उतना ही रहता है. एक बार केबल लेकर के अभी मुंबई में तो कितना केबल ले किया हुआ है अंडरग्राउंड में, जो अभी तक चल रहा है. केबल तो उतना ही रहेगा.
That is related to space. Almost 1/10 of the space you need as compared to air insulated. But sir is saying that even the cost and other factors like SFCs, which is hazardous to environment, you are saying on the other side.
For smart city installation, it is used in a foreign country.
Okay, and how last slide.
Which one consider?
Last one, before conclusion.
हाँ, बिल्कुल.
This
AI फ्रेंडली आपने बोला है ना, स्मार्ट. ऐसा पहले. हाँ, फ्यूचर एंड स्मार्ट डिजिटल ब्रेकथ्रू. Explain.
As we connect it to SCADA,
How we are? Which data it is collecting?
before 1 year I worked in a 220 kV substation. There I learned SCADA and the GIS. So they link with the SCADA and we get monitoring from inside wind indications.
No, we are talking about GIS. No? It is GIS. Your topic is about GIS.
Yes. But that is transmission line.
What kind of data you are collecting in this data?
There are also combination of GIS.
no,
Which data you are collecting from that GIS?
Data such as if the equipment is in well condition or the faults occurring in a line.
You are collecting excessive pressure,
Yeah. There is
You
a
have to
meter we
install?
can calculate.
and if the pressure is down, then you have to take the action.
maintain करो chamber में.
Yeah. Meter is
ते उत्तर है.
Next participant is Yash Sheshware Mayuresh Chavan. Participants, you have tea outside. Please take.
IT is arranged for participants.
IT is arranged. Please take.
Hello.
Start. Then on कर दो.
Hello.
First of all, good afternoon, sir and ma'am. I'm here today to present our project Smart Energy.
अरे आवाज प्लीज. तुम्हाला यांना पण आहे ना बाहेर? म्हणजे शांततेने जा, शांततेने या.
Today I'm here to present our project Smart Energy Saving and Monitoring Meter, which is LOT based solution for energy monitoring and comprehensive optimization in residential building and commercial work in future. The first question in our mind is why smart energy saving. The first question comes in our mind is that the first question is in our mind is why smart energy saving meter matters. Implementing smart energy solution is crucial for a sustainable future, offering significant environmental, economical, and operational benefits. It empowers users to reduce their carbon footprints by reducing the energy wastage and lower utility cost through optimizing the consumption of the electricity, and contributes to the more efficient and energy ecosystem for communities. Abstract the smart energy saving smart energy saving meters meter provides a real-time monitoring to the user. And the intelligent management of electrical energy consumption. It continuously monitor the voltage, current, and power energy using sensors and a microcontroller. LOT connectivity enables the remote monitoring through mobile or web application, helping user to reduce the wastage. So that meter basically is a Wi-Fi module type that connected with our phone through Wi-Fi, and that reflects our energy consumption, uses, where the energy is used, etc. In today's life, increasing use of electrical appliances has led to the higher energy consumption and electricity bills. Conventional meters only provides us simulating readings and lack of real monitoring instant insights. Real smart energy meters overcomes this limitation by offering real-time monitoring in it, and the integrated energy management. Our meter system provides a real-time insight through household energy consumption patterns through a graph or a points method.
advantages are real-time energy monitoring provides instant data of voltage, current, and the parameters. So पहले के ज़माने में like जो old energy meters होते थे, तो वो एनर्जी कंजम्पशन इन यूनिट्स बताते थे, वो भी एंड ऑफ मंथ। तो उसमें क्या होता था कि जब एंड ऑफ मंथ आता है तो बाद में तो एनर्जी सेव नहीं कर सकते, तो एनर्जी सेविंग में मेन पैरामीटर होता है कि हम लोग को रियल टाइम पता चलना चाहिए कि कौन सा एप्लीकेशन कितना वोल्टेज और कहाँ पर एनर्जी वेस्ट हो रही रियल टाइम में, तब हम एनर्जी को सेव कर सकते हैं फॉर। उसके बाद एनर्जी कॉस्ट रिडक्शन मींस अगर हम लोग ये रियल टाइम एनर्जी मॉनिटर करता है और फोन या अदर एप्लीकेशंस पे दिखाता है, तो लाइक एक मंथ मतलब एक मंथ हाफ मंथ हो गया, तो वो क्या करेगा कि आपका लास्ट मंथ का जो कंजम्पशन है, अगर हाफ मंथ में हम लोग ने उससे ज्यादा कंज्यूम किया लास्ट मंथ से, तो वो एक अलर्ट भेजता है एप्लीकेशन वेब पे, और उसका जो डिवाइस का स्क्रीन है उस पे भी अलर्ट्स आने चालू हो जाते हैं, तो वो देख के आप एनर्जी बाद में सेव कर सकते हो। इसके बाद IoT बेस्ड रिमोट एक्सेस मींस मोबाइल एंड वेब एप्लीकेशन से आप एक्सेस कर सकते हो। मींस अगर आप घर के बाहर किधर भी होगे तो आप एनर्जी कंज्यूम कितनी हो रही है, मतलब अभी हम लोग घर घूमने जाते हैं तभी फ्रिज या फिर ऐसे लोड्स होते हैं जो नेसेसरी चालू रखने पड़ते हैं, और अगर उसमें कौन सा फॉल्ट हो गया तो वो हाई करंट खींचेगा, तो वो अलर्ट भी भेज देगा, तभी मतलब प्रोटेक्शन भी करेगा। उसके बाद एनर्जी वेस्ट रिडक्शन की लाइक वो रियल टाइम एनर्जी देगा, तो फिर हम खुद अपना घर का एनालिसिस करके एनर्जी वेस्ट को रिड्यूस कर सकते हैं। उसके बाद यूजर अवेयरनेस एंड कंट्रोल मींस वो डिस्प्ले पे अवेयरनेस देता रहेगा, मतलब आते जाते भी आपको पता चलेगा कि कुछ अनयूजुअल हो रहा है। तो उसके बाद एनवायरमेंटल बेनिफिट्स, अगर हम लोग एनर्जी अभी सेव करेंगे इंडिविजुअल घर का भी, तो जैसे कि थोड़े थोड़े लोड होते हैं जो हम लोग यूजुअली इग्नोर कर देते हैं, तो वो अगर हम लोग सेव करेंगे और अगर हर घर थोड़ा थोड़ा एनर्जी सेव करेंगे तो वो बहुत बड़े एनर्जी सेव करने के कंट्रीब्यूट करेगा। उसके बाद इसके डिसएडवांटेजेस भी मेंशन किए हैं, लाइक इसको 24 आवर्स इंटरनेट कनेक्टिविटी लगेगा अगर आप ऐप और वेब यूज कर रहे हो। उसके बाद लिमिटेड एप्लीकेशन लेवल मॉनिटरिंग, मतलब हम लोग हर एक लाइक एक रूम है उसके अंदर बहुत सारे एप्लीकेशंस लगे होते हैं, तो हम लोग हर एक इंडिविजुअली तो मतलब इकोनॉमिकली नहीं है हर एक को मॉनिटर करना, तो हम लोग क्या करेंगे कि जो हाई एनर्जी कंज्यूमिंग है और लो एनर्जी कंज्यूमिंग है हम लोग वैसे ही डिफरेंशिएट करेंगे। उसके बाद डेटा सिक्योरिटी कंसर्न्स मींस अभी इसमें वेब और ऐप से तो डेटा वायरलेसली जाएगा, तो फिर उसमें साइबर सिक्योरिटी मतलब कोई भी हैक कर सकता है वो। और उसके बाद सेंसर एक्यूरेसी लिमिटेशन मींस अगर आप हम लोग ने ज़्यादा एक्यूरेट सेंसर्स लेने गए तो वो स्टार्टिंग में जब इंस्टॉलेशन होता है तो इंस्टॉलेशन कॉस्ट बढ़ सकता है उसका। उसके बाद हार्डवेयर कंपोनेंट्स में हम लोग यूज करेंगे ESP32 माइक्रो कंट्रोलर फॉर वायरलेस कनेक्टिविटी, एक करंट ट्रांसफार्मर जो इजीली क्लैंप होके करंट बताएगा, फिर एक वोल्टेज सेंसर जो वोल्टेज बताएगा, और एक LCD डिस्प्ले जो अवेयरनेस क्रिएट करने के लिए। उसके बाद ये ब्लॉक डायग्राम है कि कैसे वर्किंग प्रोसेस है, तो उसमें सबसे पहले पावर सप्लाई जाएगी सेंसर्स को जो लोड को मॉनिटर करेंगे, उसके बाद वो ESP32 को भेजेंगे, वो फिर जो यूजुअल एनर्जी यूसेज है उससे मैच करके अगर कुछ फॉल्ट होगा तो वो अलर्ट वगैरह होगा, वो IoT इंटरफेसेस है वो वाईफाई को भेजेगा और फिर क्लाउड पे जाकर आपके एप्लीकेशन में अपडेट हो जाएगा। और उसके बाद एक डिस्प्ले का भी मॉड्यूल है जो कि जिस पे भी अपडेट हो जाएगा। उसके बाद रिले मॉड्यूल है, अगर आपका कंजम्पशन एक हद से ज्यादा हो गया तो फिर आप उसमें ऑटो कट टाइमर भी लगा सकते हो, मतलब इतना इतना कंजम्पशन होने के बाद वो ऑटो कट कर देगा जो भी लोड को कट करना है। उसके बाद कंक्लूजन एंड फ्यूचर स्कोप में the system offers a cost effective and scalable solution for real time energy monitoring, promoting efficient energy usage and reducing wastage. Future enhancement include application level monitoring, मतलब हर एक एप्लीकेशन को हम लोग मॉनिटर कर सकते, वैसे अपग्रेड डाल सकते हैं। उसके बाद ऑटोमेटेड लोड कंट्रोल मींस हम लोग IoT के थ्रू किधर भी हो गए तो लोड को ऑटोमेटिकली ऑफ या ऑन कर सकते हैं। उसके बाद एडवांस डेटा एनालिसिस एंड सोलर एनर्जी इंटीग्रेशन। अभी जो ये एनर्जी मीटर है वो भी थोड़ी सी एनर्जी खाता है, मींस उसको काम करने के लिए, तो हम लोग फ्यूचर में वो पूरा सोलर से भी एनर्जी दे सकते हैं, मतलब वो जो होम यूनिट है उससे कम खाए।
तुम्ही डिझाईन केलं स्मार्ट मीटर की तुम्ही इन्फॉर्मेशन
फायनल इयर प्रोजेक्ट
तुमचा लोड कसा कट करायचा?
सो तुम्ही लिमिट सेट केल्यानंतर रिले मॉड्यूल तर असेल, तुम्ही ESP थ्रू ते मॉनिटर करणार तुमचा लोड काय, पण जर तुमचं लिमिटच्या बाहेर जर गेला तर मग ते कट होतं।
काय करतो?
लोड हा म्हणजे वॉर्निंग येणार तुम्हाला, पाहिजे तुम्ही वॉर्निंग सेट करू शकता, पण जर ते वॉर्निंग पण खूप अभाव गेला तर मग कट होणार ऑटोमॅटिक।
टोटल म्हणजे सप्लाय करतो?
हा सप्लाय, पण ते तुमच्या म्हणजे तुम्ही अकॉर्डिंगली कंट्रोल करू शकता की कसं कधी कट व्हायचं।
नाही, कुठला लोड, आता एक घर आहे तर त्याच्यामध्ये वेगवेगळे रूम्स असतात, तर स्पेसिफिक रूम्सचं पण आम्ही रिले मॉड्यूल कनेक्ट करून करू शकतो, म्हणजे एक स्पेसिफिक रूमचं
नाही,
कनेक्ट।
सरांचं म्हणणं आहे की समजा ओव्हरलोड झाल्यावरती सप्लाय पूर्ण डिस्कनेक्ट होणार नाही, पूर्ण नाही, म्हणजे तो जो आता स्पेसिफिक रूम म्हटला त्याच्यामध्ये, तर मग ओव्हरलोड कोणता झाला तुम्ही ते तिथे पण देताय का, त्याला वेगळा सेन्सर देताय का, किंवा काय तुमचं सिग्नल आहे तो देताय का? मग आपलं घर म्हटलं की आपण अप्लायन्सेस जे वापरतो दॅट इज गोइंग टू बी युजफुल, आपण असं अननेसेसरी खूप कमी ठिकाणी असतो, अदरवाइज वी आर विथ इफिशियंट।
बट हे होमसाठी पण टाकू शकतो आणि इंडस्ट्रियल यूजसाठी पण असू शकतं ना स्मार्ट एनर्जी।
हो, तर मग ते लोडच्या बाबतीत आपला जो प्रश्न होता,
कोणता लोड कट करायचा हे तो स्वतः डिसाईड नाही करत,
नाही
तुम्हाला डिसाईड करून द्यावा।
म्हणजे आता सारे रूम्स आहेत, तर ज्या रूम मध्ये सर्वात जास्त लोड घेत आहे तो तोच रूम कट करणार, बाकीचे
आपल्याला त्याचीच गरज असली तर
त्याला कळेल कसं की तो रूम जास्त
ते जे करंट ट्रान्सफॉर्मर लावलंय
तो तर तुम्ही एकच लावलं ना, प्रत्येक रूम साठी वेगळा करंट,
प्रत्येक रूम साठी वेगळं
स्पेसिफाईड असतो
म्हणजे त्या सगळ्या सिटी तुम्हाला प्रत्येक रूम मध्ये जे करंट गेलेलं आहे, केबल गेलेली आहे, तिथे प्रत्येक सिटी लावावं लागेल आतमध्ये।
नाही, आम्ही जो एनर्जी मीटर जिकडून लाईन जाते ना तिकडेच डिवाइड करणार त्याला, म्हणजे प्रत्येक रूमला वेगवेगळी लाईन जाते ना, जे MCB थ्रू तिकडेच जे डिवाइड
बसवावं लागेल तुम्हाला प्रत्येक MCB।
काही प्रायोरिटी देता येते का, की मला माझ्या घरी समजा लाईट चालू आहे किंवा कोणाच्या आईच्या घरी, आणि मग त्याच्यामध्ये जर ओव्हरलोड झालं तर माझ्या प्रायोरिटी प्रमाणे मला 1000 रूमचा कट झाला तर आय डोंट माइंड, म्हणजे मला त्याचा काही प्रॉब्लेम नाही, हो प्रायोरिटी देऊ शकतो आपण, आणि स्पेसिफाईड म्हणजे एकाच लोड पण आपण म्हणजे तुम्ही दोन्ही बोलताय ना, ओव्हरलोड ज्याचा जास्त आहे ती रूम पण तुम्ही कट करायचं
नाही। आता
प्रायोरिटी कॅन बी गिव द प्रायोरिटी टू द स्मार्ट मीटर,
हा ते ऍप थ्रू देऊ शकतो ना, म्हणजे ते ऍप थ्रू सांगायचं की या रूमचं काय पण झालं तरी ऑफ करायचं।
ते ऍप कोणी बनवलं?
ऍप डेव्हलप नाही केलं,
ऍप अजून डेव्हलप
करायचं
ऍप नाही,
हार्डवेअर बनायचं। थँक्यू।
झालाय का तुमचा?
That's last.
So our final participants are Himanshu Borse and Bhavya Yadav. Bhavya Yadav.
So, good morning, madam, all present here and respected judges. My name is Himanshu Borses and he is my friend Bhavya Yadav. Our topic is AI in electrical engineering, in which we have specifically chosen AI in smart grids. Let's get into it. First of all, this is our overview of the paper. It's just basic concept, we'll skip that because it's a bit lengthy. Firstly, rising demand. Why we need AI in our power system these days? Firstly, this is the diagram of recent data which are calculated. It's in 2030, so it's just a prediction. It's in data center power in terawatt hours. It shows how demand has been rising and rising. Due to AI implementation, it will further rise in the future. It also shows power efficiency gains which have been increased due to AI and how it will increase further in the future. Next, traditional grid. Firstly, these are our normal grids which are available today. It consists of generating station, step-up transformer, transmission, customer step, substation, step-down transformer, three-phase primary, single-phase or residential. It's traditional grid which is implemented even today. Next, our evolving is smart grid. So this is smart grid and this is basic concept of the smart grid. It will consist of a central controller which will link everything in it so that monitoring and everything else like fault detection, efficiency, energy losses will be easier to recognize and then plan. So you can see in this diagram it is connected to microgrids, which is like a whole area who has its own generating station, solar panels, renewable energy, then transmission substations, regional controllers, homes, offices, and etc. Next, role of AI. What is exactly role of AI in our smart grids? Predictive maintenance, optimization, advanced grid management, cybersecurity measures, and fault detection. These are some of the AI techniques which are being used, which are being implemented. First of all is ANN. We'll learn about all these techniques later. ANN, fuzzy logic, reinforcement learning, and then optimization techniques, which includes genetic algorithm, particle swarm, and ant colony. Firstly, ANN, artificial neural network. Now, I'll use this diagram to explain it very simply. First of all, it consists of three nodes. Not three nodes, it can be, these are called nodes and they are inputs. It can be n number of inputs. Then W1, W2, Wn, they represent weight. So W1 will carry higher weight, W2 will carry less than that, and etc. Neuron, this will be the main central processing unit where everything will be added and one singular output will be sent. Now, for example, we'll take an example of short circuit fault in which X1 will be line current, X2 will be bus voltage, and X3 will be frequency. Now, during short circuit fault, line current will deviate the most. So, W1 will be X1, and W2 will be bus voltage, and W3 will be frequency. Now, in neuron, it will see that line current is deviating the most, so it will send one singular signal to the output, making it more faster and more accurate. This concludes our ANN. Then next up is fuzzy logic controllers. What exactly it does is, it takes input from the sensors, voltage, current, etc. Then it goes into fuzzy fire. Fuzzy fire is basically the language for the AI. It converts normal values, numerical values into linguistic variables. Then it goes to the control block, where it decides what to do next, and defuzzifier, which sends it through the system to be controlled in its format where it will understand. For example, if voltage is low, fuzzifier will see it and it will be not be numerical value. Instead, it will be linguistic variable, which means instead of numerical, it will be language or words. It will say low voltage, medium voltage, high voltage, etc. control block, it will send the signal to defuzzifier, and defuzzifier will say increase the excitation, decrease the excitation, etc. Next is reinforcement learning. This is basically trial and error of AI. Okay, what it does here is environment. Okay, first of all, it takes the value from the environment. For example, it's voltage in our case. Then state. It sees if it's low, medium, high. Then action. It tells what the system should do. And reward. It sees if reward is getting or not. It works on the basis of punishment and reward. In case of AI, punishment and reward is like if there is any fault and it is clear, it will be reward for the AI. But if not, it will take it as a punishment. It will learn from it and not repeat it in the future. Like this, millions of times it is being done. Then AI-based optimization techniques. First of all is genetic algorithm. Genetic algorithm is based on Darwin's theory, which says survival of the fittest, which means human beings are evolved and they adapt to their environment to live more peaceful and better life. This is what exactly AI does here. Now, for example, I'll take an example of LDC. Okay, if we are forecasting the load and we want to do it in the most economic way. For example, there are 3 generators. Now, what it will do is it will generate a singular for prediction of generators, how much it should generate, so it will meet in the most economical way. Now, a singular guess will be called as chromosome, and it will do multiple guesses, which will be called as population. Now, after doing that, it will see that which one gives us the most lowest cost for the most amount of to meet the load forecast. And then after meeting it, it will have 2 more things, which is crossover and mutation. Crossover, it will mix 2 lowest values, which will give us the most lowest load demand meeting, and then other will be mutation. It will slightly change the values to meet it. Next is particle swarm. Imagine this as a flock of birds. They are in air scouting for food. This is what AI does here. It's in singular forms. Like, for example, one bird will be one AI. It will find optimal paths to maybe power flow for power flowing, and it will act according to it. Then is ant colony. Now what ant does for survival is, whenever they see a food, one ant will go to it and see if it is the shortest route, and then it will come back and it will inform other ants. Then by this phenomenon, ants travel the shortest route to find the food and grab the food. If one ant finds the shortest route, other ants join them. By this, we can see that where most of the ants are going, and it will give us the shortest route. Now, how this is useful in power system? It can be used in finding the power flow path. Multiple ants will go. Is basically AI in this. AI will go and find the shortest route, and where there are the most ants, that is the shortest route for us. Next up is applications of AI in smart grid, which Bhavya will explain.
So hello everyone, myself Bhavya. I'm going to explain about the AI application. So first we are getting here smart grid architecture. So second we get the load forecasting. After that, renewable integration, fault detection, demand side management. So first here is the smart grid architecture. So we will go from bottom to the top layer. So the first layer is about component layer, which consists of physical devices like transmission, generation, and distribution. And the second is about communication layer, which passes the information to the control center. And third is information layer, which controls your all kinds of information, data storage and data entry process. Fourth is function layer, which consists of demand side management and load forecasting. And fifth one is the business layer, which is the topmost layer, which controls your marketing strategy and making the business tariffs. So now the load forecasting. Now how will AI will manage the load forecast? So first of all, it will predict your behavior from previous data, and according to make the timeline. Getting an example, on weekend you use more energy as compared to the weekdays. So according to this will predict the data and give to the utilities. Now next is our fault detection. So we are going from again bottom to the top. First we get the managed system. For example, transmission and other devices are working, and second the monitoring, which is continuously gets monitored. For example, there is any kind of fault detection. So root cause analyze will analyze which kind of fault is happened because of overheating or kind of any fault damage. After that, it will go to the fault prevention and recovery, which isolates the faulty part and make the systems healthy. Now demand side management. So first of all, on the top of the block, which describes that managing demand side control using AI. Now second is meta heuristic algorithm, which is a complex problem solving technique. Now next is quantum machine learning, using quantum computing and machine learning to solve the complex programs. Now next is machine learning and reinforcement, means learning from the previous data and getting improvement decisions. Now next is data management and cyber security. As this is a demand side management, so we are mostly using the consumer's data. So their security is to be needed. Now the next is blockchain technology for demand side management, which means a transaction of transparency energy. Now the next is consumer participation and incentivation. Because of this, we use any kind of rewards or incentivation to control the demand side management and turning into a reward. Now next is outcome. Now our first outcome is energy efficiency, which is using wasting the lowest energy. The second is scalability, which is working for small and large kind of works. And third is security and privacy, as I already said, need to be protected. And the fourth one is flexibility, which is working for all. And number 5 for resilience, which means learning from the previous data and changing the decisions.
You just concluded.
The conclusion.
Okay, so for conclusion, I would like to say that AI plays a vital role in our smart grid, which will be implemented in further in the future. It is still being implemented, but it will obviously go on a larger scale in the near future. So AI plays a vital role in optimizing the smart grids, enhancing the efficiency, increasing the reliability, and a lot more things like prediction, fault, and etc. In that, I would just like to say, AI will not replace engineers. It will just make the smart grid more smarter and efficient to use. These are our references.
This presentation, what are the limitations?
Actually, the limitations are about the installing the initial cost and cyber. The limitations are high initial cost, installing cyber security, which needs to be protected, and we require the skilled workers to control these AIs.
And you have used this AI technique in your presentation. So how it is used? Means for what improvement?
So like we have discussed multiple techniques. First of all is ANN, which
AN is alright. AI, you just go. This is artificial.
Fuzzy.
Okay. AI.
Reinforcement optimization techniques. Okay. So genetic algorithm. Firstly.
So only one algorithm you have used, GA?
Particle swarm and ant colony too.
Particle swarm, ant colony, and then GA.
GA, yes.
Okay, this is for AI based. Now just okay.
Demand side management, renewable energy integration.
Now this demand side management, so what is the difference between just our this normal demand and this AI based demand side?
So actually normal demands we are getting the previous one, and the AI based is more complex. So if we use the AIs to solve this problem, actually we have quantum machine learning to solve the complex problem as quickly as possible.
But exactly it is deciding. How will it handle it?
So mostly solve the complex problem now.
So in that outcomes you have last one, flexibility and resilience.
Resilience. So flexibility means it is beneficial for small and full loads, so smaller to higher loads. And the resilience means learning from the previous mistake and improving decision over time to time.
Means that previous data you can preserve and
you can preserve
for your
it.
better. अभी इधर आगे से प्रीडेक्टिव मेंटेनेंस का मतलब
So predictive maintenance is, for example, if there is any kind of a fault in your previous one, and this will go to your data restoration, which is your previous preset data. And after that data storage, then you can see, as you can see, the upper block is what ERP, which means enterprise resource planning. But in terms of predictive maintenance, ERP means your track record, your previous one, and quality means your current, what's your current quality of the equipment, and MES means how much system is get defected. And after this, AI predictive will give you a dashboard or alertness that your system is getting default to solve this problem as quick as possible.
साइबर सिक्योरिटी रिस्क के लिए क्या है?
So cyber security means mostly अगर जैसे साइबर सिक्योरिटी हैक होते हैं तो फिर हमको कोई हाई कॉन्फिडेंस की ऑटो क्वांटम मशीन्स होगा, इससे फिर हमें स्ट्रॉन्ग पासवर्ड सेट करना खाली हायर अथॉरिटीज और फिर कंज्यूमर साइड से ही दोनों खाली उस डेटा को एक्सेस कर सकते हैं, बाकी कोई थर्ड पार्टीज कोई डाटा को एक्सेस नहीं कर सकते। ऐसे कोई स्ट्रॉन्ग या फिर कोई कोड क्रिएट करना सो दैट आपका जो पर्सनल डाटा है वो सेव हो।
And even in future, maybe AI will take over. If you share too much information with AI, it can get leaked or it can delete it if any malfunction kind of happens. This is of course a possibility in the future.
AI पेंडर बन जाएगा तो
AI is which is beyond the human mind and human brilliance. So they just go. भी हम लोग AI okay.
So as we have done with all our 15 presentations, I request all the participants to kindly wait for the results. We will start the validation function within 10 to 15 minutes. Please submit your feedback forms to Manas. Good afternoon, everyone. We have with us a scrutiny member, Mrs. Rajeshri Umesh Patil. She is working as a HOD from June 2023 onwards in VPM's Polytechnic, Thane. Also, ma'am is pursuing PhD from Sardar Patel College of Engineering, Andheri. We welcome you here, ma'am. I would like to request our Vice Principal Sir to kindly felicitate Mrs. Rajeshri Umesh Patil, ma'am. Thank you, sir. I would like to request a few participants to kindly share your experience. Anyone, please? Himanshu.
बोलो बोलो कोई तो बोलो प्लीज बी वॉलंटियर बोलो कैसा हुआ प्रोग्राम क्या हुआ
Any suggestions?
कुछ है तो बोलो
I would like to first of all thank you everyone and MSBT for organizing this event. It was really grateful for us. We got to learn new things, doing research, understanding about upcoming trends in electrical and all the topics which were present. I absolutely loved it. All the organization was good. We were well treated also. Everything was good. I just loved it. Thank you.
Sharatha.
next any girl be ready
It was all nice to attend this program, and due to this program, we came to know about many things that we didn't know apart from our studies. Actually, so I would thank MSBT for hosting this, MSBT and Bharati Vidyapeeth for hosting this program. Thank you.
Any participant? Kindly share your views. Some suggestions. Saish.
Thank you MSBT and all the principals and teachers and committee, and congratulations to every participant for the excellent work. Keep improving and keep presenting. Thank you.
Now I would like to request our jury members to kindly share your views.
Organization team and the participants from the various institutes there. We are so lucky that our affiliated main organization, Maharashtra State Board of Technical Education, is really encouraging and motivating to our institutes as well as the students, those who are learning in that respective institutes there. Every year they are organizing, they are means having these kind of programs, and at the start of the academic, they will inform on their portal that the institutes, those are interested to conduct these kind of programs, paper presentation, quiz competition, or even the project exhibition. Then the interested institutes are showing their interest, and accordingly, again to the merit, means what kind of infrastructure, whether the institute is in a position to conduct that, and that too again a region wise. So MSBTE is having 4 regions in Maharashtra, and almost in all the regions they are organizing for all the programs there, not only for electrical, even for all the programs there. And so really we are very much thankful to our Director of Technical Education as well as to the Director of MSBTE, our Joint Director of the Mumbai region. Then the institutes, those are organizing because they have to take a lot of efforts there. So you can consider in for your institute also, see the preparation, how they have to prepare, right from your leaflets and all that, and sending the forms and receiving the forms and receiving the papers. So many more activities are there, and then it is going to be a big success for this kind of programs there. Today I am lucky that I have been get a chance over here to come as a jury member, and somehow I am satisfied with the today's presentation because that is related with the, you can say, emerging trends in our electrical engineering there. So those institutes have participated. I am thankful to their principal, head of department, staff, though have, because some of the staff they have to help their students there. They have to guide how to write the paper. Say, getting the first, second or third number is not a matter. You should not be really discouraged by any result there. But definitely, as and when you come over here and throughout the day, whatever you have seen the presentation of your various students, so you might have get some ideas, something is there. So definitely a number is not a matter and nobody should not be discouraged there. हमको कैसे अभी कोई तो नंबर निकालना ही है, तो इसका मतलब ये नहीं कि बाकी किसको मिला नहीं, तो देयर इज ऑलवेज अ स्कोप. यू आर द टेक्नोक्रेट्स, टेक्नोलॉजिकल स्टूडेंट देयर. सो आप कोई भी टॉपिक को ले लो, आपको वहाँ पे स्कोप है. आप यहाँ पे आपका प्लेटफॉर्म आपको मिला है, आपको एक थोड़ा डायस मिला है, तो आपको मतलब जो एनकरेजमेंट मिलता है यहाँ पे डायस पे आके बोलने का. अभी किसी को फर्स्ट टाइम होगा, वो लोगों को थोड़ा बोलने में दिक्कत आता है, बट दैट इज नॉट अ मैटर. आपको यहाँ पे आके आपने जितना भी आपकी तरफ से ट्राई किया है, इट इज मोस्ट वेलकम देयर. और मैं आपको सबको यही मतलब ये दे दूंगा कि जस्ट डोंट be bother about anything there. As and when there are the competition, please participate in the competitions and show whatever the talent you have there. Maybe in any language. Language is never a barrier for any progress there. So thank you coming over here and presenting your papers there. And thank you to the complete organization team, Rajita madam, their department, Vice Principal sir, and those who have been directly or indirectly involved to success this program. I am thankful to all of them. Thank you.
Thank you, sir. Ambekar sir, please come.
Hello, good afternoon. First of all, I want to thank Ms. Tandon sir, Principal sir, Vice Principal Patil sir, Ranjita ma'am, Savarkar sir, and all the team to give me such opportunity to come here and listen all the presentation given by you. खरं सांगायचं तर प्रेझेंटेशन आता जज करायची माझी पहिलीच वेळ होती, पण पाहिलेले सगळ्यांचे प्रेझेंटेशन खूप सुंदर होते. प्रेझेंटेशन मध्ये डाटा सुद्धा सगळ्यांचा सुंदर होता. फक्त आता कमी जास्त कुठे होतं तर तुम्ही जो डाटा आहे, तुम्ही जो प्रेझेंट करताय तो तुम्ही कितपत वाचलेला आहे, किंवा त्या गोष्टीमध्ये शब्द जो लिहिलेला आहे तो तुम्ही कितपत सर्च केलेला आहे. कारण तुम्ही ज्यावेळेस एखादं प्रेझेंटेशन देताय तेव्हा ते प्रेझेंटेशन हे तुम्ही देताय, हे दुसरं कोणी बनवून नाही दिलेलं. तर मग पाहणाऱ्याला ते पटलं पाहिजे की ते तुम्ही बनवलेलं आहे, तुम्ही त्याच्यातल्या प्रत्येक गोष्ट वाचलेली आहे, ती तुम्हाला समजलेली. त्यामध्ये एखादा शब्द जर आलेला आहे राऊंड ट्रिप म्हणजे काय, तर मग आता तुम्ही त्याच्याविषयी सर्च केला पाहिजे, की नाहीतर तुम्ही ठेवून काय उपयोग आहे. तर एकंदर प्रेझेंटेशन मध्ये जे काही डाटा होता तो अत्यंत सुंदर होता. मी आता 400 kV खारघर सबस्टेशनला काम करतो MSBTE पॉवर सेक्टर मध्ये. त्यामुळे आपल्या इथे जे जवळपास प्रेझेंटेशन झाले ते रिलेटेड टू माय फील्ड्स होते. ड्राईव्ह, इलेक्ट्रिकल ड्राईव्हचा हा एक पोर्शन सोडला तर त्या दृष्टीने मी बघितलं तर एक्झिस्टिंग जे प्रेझेंटेशन मध्ये आहे त्या जवळपास सर्व गोष्टी आजकाल इम्प्लिमेंटेशन मध्ये येत आहेत. तुम्ही जर थोडासा सर्च केला, जे तुम्ही प्रेझेंटेशन मध्ये दाखवलेलं आहे ते इन फ्युचरमध्ये नाही, ते आता सध्या टेक्नॉलॉजी वापरण्यास सुरुवात झालेली आहे. म्हणजे तुम्ही आता ऑन द वर्ज आहात. म्हणजे आता जे प्रेझेंटेशन येणाऱ्या फ्युचरमध्ये ती म्हणजे इट इज रिअल फ्युचर ऑफ आवर पॉवर सेक्टर. तर नंबरच्या दृष्टीने फक्त एवढं आहे की तुम्ही जेव्हा प्रेझेंटेशन आम्ही आता बसून ज्यावेळेस बघितलं तेव्हा तुम्ही कितपत कॉन्फिडेंटली बोलताय, तुम्ही बनवलेलं प्रेझेंटेशन मध्ये तुम्ही किती वर्क केलेलं आहे, या गोष्टी त्यामध्ये जास्त इम्पॉर्टंट होत्या. बाकी प्रेझेंटेशन सगळ्यांचे चांगले होते. त्यामुळे थँक्यू सगळ्यांना. तुमचं प्रेझेंटेशन सगळ्यांचंच छान होतं. थँक्यू.
Thank you very much, jury members, to share your valuable feedback. And now I would like to request Vice Principal Sir, J.K. Patil Sir, to kindly share your views.
I will not take much of your time because you are waiting for the results. Already the result is, I want to share something with you. First, I have to congratulate all of you for sharing the stage for this paper presentation. Everyone is a winner. So give a clap for yourself. So MSBT, as I have told, MSBT is taking lots of efforts for your generation to come. MSBT has taken one more initiative, one more step. They have started incubation centers in various colleges. So ours is the one of the college for we have been allotted incubation center, that is for startup. If some of you want to take the advantage of that, you can approach us with some good startups. So you will get help from us. The efforts taken by the team, I think it was nice. अच्छा था क्या नहीं था? अच्छा था ना? होस्ट अच्छा था क्या नहीं था? हमने सर्विस अच्छी दी कि नहीं दी आपको? दिए है ना? दिए तो ताली बजाओ फिर. ठीक है. तो ये जो प्लेटफॉर्म है आपको इंस्टीट्यूट करना है, नया सीखना है उसमें, है ना? मायूस हो के मत जाओ यहाँ से, कुछ तो लेके जाओ. प्राइज मिले ना मिले वो बात नहीं है. तो ये जो सर खड़े हैं यहाँ, इज मिस्टर कुमार, ही इज अवर टीचर. सुबह 10:30 बजे से यहाँ खड़ा है और आपको लाइव यूट्यूब पे दिखेगा. यूट्यूब पे आप घर जाएंगे तो आप जो यहाँ बोले आपको वहां दिखेगा कि मैं स्क्रीन पे कैसे दिख रहा हूँ. सो गिव हिम अ बिग अप्लॉज फॉर कुमार. So thank you very much. I will not take more time. Thank you very much.
Thank you very much, sir. Wow, what a fascinating and nail-biting competition we have had today. We are privileged to witness such an enthralling matchup. Participants have been truly excellent today and they have raised the bar of competition. Every paper presented today reflected hard work and innovation. While all of you are winners in our eyes, the judges have reached a verdict. I would like to extend our deepest gratitude to our panel of judges for their meticulous evaluation and constructive feedback. A big shout out to all the participants who showcased exceptional research and insight. A round of applause to all the participants here. So the jury members today must have faced a situation posed by our competitive participants by their smart responses. So any guesses? Who's the winner? First, second, third? So now I would like to request our jury members to kindly announce the results.
Before announcing the result, just keep in mind that these results are completely based on some concepts and basics there. Means institute have been given the parameters, and based on that parameters, 30-70 ratio, 30 for your scrutiny of your paper and 70 for today's presentation there. So considering that parameters, here your results are there, and we will start with the third one. Name of student and name of
the third prize goes to SVKM Shri Bhagubai Mahatlal Polytechnic and College of Engineering, Green Hydrogen and its Future in Power Sector. Aradhya M. Gaikwad and S. R. Kadam. Sir,
please, Aradhya. Your good name? Yes. Yes.
एक मिनट एक ग्रुप फोटो ले लीजिए दोनों बीच में आ जाओ पार्टिसिपेंट्स
Second prize goes to Rajaram Shinde Institute of Engineering and Technology, Pedambe. Those students, yeah. For these institutes, the students who have been presented is Vedika Praveen Lingayat, Shravani Sandeep Shivgal. Please welcome. Vedika.
And finally, here is the winner. Any guesses from the audience? Yes, I am going to announce. It is VPM Polytechnic Thane AI in Electrical Engineering. Yes. Himanshu Bose and Bhavya Yadav. Himanshu Bose and Bhavya Yadav. VPM Polytechnic Thane AI in Electrical Engineering.
Congratulations to all the winners. I would like to request Mrs. Lovely Gaur ma'am to kindly give away the vote of thanks.
So just announce that after the
Participation certificates will be given after vote of thanks. Kindly wait, all the participants.
Good evening, everyone. It is my privilege to propose the vote of thanks for this wonderful gathering. First and foremost, I would like to thank MSBTE to trust us and give the opportunity to conduct this program, which provides students a platform to come out with their creativity and innovative ideas, and also improve the values required to thrive in the competitive global market. I would like to express our deepest gratitude to our jury members, Dr. P.N. Pathan sir and Mr. Shekhar N. Ambekar sir, and scrutiny members, Mr. Yashin Mapara sir, Mrs. Aryu Patel ma'am, and Mrs. Ashwini Patel ma'am, for taking their precious time out of their busy schedule and to provide insightful feedback to our participants. A special thanks to the student participants who presented their ideas today. Their energy and presentation style during the presentation was spectacular. Their work is a testament to the fact that technology is best when it brings people together. I also thank our principal, Professor P.N. Tandon sir, for his valuable guidance and support towards organizing this event. I extend my sincere thanks to our Vice Principal, Mr. J.K. Patel sir, for his support as and when needed. Also, our sincere thanks to our HOD, Mrs. Rajita TV ma'am, for her continuous support, guidance and encouragement to conduct this event smoothly. I must express my appreciation to the organizing committee, volunteers and IT team of BVIT for their tireless efforts in making this event a success. We are leaving with a lot of ideas and everlasting memories, and I hope we keep pushing the boundaries of technology. Thank you. At last, let this not be a goodbye, but a heartfelt thanks to you until next time. Now, I ask everyone to stand up for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I request participants to kindly take your certificates. I'll take your names. Vedika Lingayat, Shravani Shigavan. Vedika and Shravani.
Come fast, come fast.
Next, Rehan Shah and Manoj Rajbhar. Kindly come. Please come forward. Vaibhavi Kandale and Shalaka Maskar. Vaibhavi Kandale, Shalaka Maskar. Prisha Thakkar and Hemish Desai. Prisha Thakkar, Hemish Desai. Aradhya Gaikwad, Yash Kadam. Aradhya Gaikwad, Yash Kadam. Om Jadhav, Aditya Rathod. Mohammad Suleiman and Shardul Khade. Mohammad Suleiman, Shardul Khade. Yash Eshware and Mayuresh Chavan. Yash Eshware, Mayuresh Chavan. Badal Vishwakarma, Saish Gaikwad. Badal and Saish. Aryan son of Om Walunj. Aryan son of Om Walunj. Sahil Mhatre, Aniket Chalke. Sahil Mhatre, Aniket Chalke. Sahil Mhatre. Himanshu Borse, Bhavya Yadav. Himanshu and Bhavya. Paras. Himanshu, Bhavya. Paras Mistry and Jairam. Paras Mistry, Jairam. Purushottam Sharma and Mohammad Ali. Purushottam Sharma, Mohammad Ali. Tokir Khan and Anas Kotmire. Tokir Khan, Anas Kotmire. Thank you very much all the participants.